let me ask you a question. What do you think is the most terrifying thing in the world? Is it sudden death, pain, loneliness? No, none of those. The most terrifying thing is knowing that you are going to die and realizing there's absolutely nothing you can do about it. All you can do is wait for that day to arrive, and that's exactly what's happening to the universe. Physicists have already figured out how the universe will die, when it will die, and what form that death will take. What's even more unsettling is that there is no way to stop it. This ending is called heat death. It's not an explosion, not a collision, not something being swallowed by a giant cosmic monster. It's everything coming to a stop. All stars burn out. All black holes evaporate. All atoms fall still. The entire universe becomes an infinitely large tombstone. No light, no heat, no sound, only eternal silence. You might think this sounds like science fiction, but it's a conclusion derived from the most rigorous mathematics we have. What's even more disturbing is that this isn't caused by some outside enemy. It's a built-in flaw in the universe itself, like a car that eventually runs out of gas. The universe is destined to shut down. So why does this bug exist? Who designed it this way? The answer is hidden in a cup of hot water. Hot water cools down. Everyone knows that, but have you ever asked yourself why cold water never heats itself up? You'd probably say, that's obvious. Heat flows from hot to cold, but why can't it flow the other way? Physicists spent more than a century thinking about this and reached one conclusion. It's not impossible. It's just unbelievably unlikely. So unlikely that the lifetime of the universe isn't long enough to wait for it. That's the real meaning of the second law of thermodynamics. It doesn't say something is impossible. It says it's almost impossible, and that almost is the universe's death sentence. Let me show you why. Imagine a box with 100 gas molecules, all squeezed into the left half. That's an ordered state. Now remove the divider. The molecules spread out and eventually fill the entire box evenly. That's a disordered state. Here's the question. Could those molecules ever, on their own, all return to the left side? In theory, yes. Their motion is random, so every arrangement has a probability. But what is that probability? 1 in 2 to the power of 100. You would have to wait about 10 to the power of 30 seconds to see it happen once. That's a trillion times longer than the age of the universe, and that as with only 100 molecules in 1 liter of air, there are about 10 to the power of 22 molecules. If you wanted that air to spontaneously gather into a corner of the room, you'd have to wait longer than any number we can meaningfully describe. That's why you never see scattered playing cards rearrange themselves, a shattered vase repair itself, cold coffee heat itself up. It's not that physics forbids it, probability forbids it. Now, scale this up to the entire universe. At the beginning, the universe was extremely hot and dense. All energy was packed into a single point. That was the most ordered moment in cosmic history. Then came the Big Bang. Energy spread out, temperatures dropped, matter formed, stars ignited, planets appeared, life emerged. But every step of this process consumed order. Every nuclear reaction, every transfer of heat, every chemical process. All of it increases disorder. The universe is like a giant block of ice that is slowly melting. While it melts, it can become water. It can form rivers. It can shape landscapes. It can give birth to life, but melting is irreversible. Once all the ice turns into water, it will never freeze itself back. So how long can this cosmic ice last? The universe is now about 13.8 billion years old. Let's take today as our starting point. 10,000 years from now, human civilization may still exist or may be gone. The universe won't care. Stars will still shine. Galaxies will still spin. Everything will look much the same. 10 billion years from now, the Milky Way will collide with Andromeda. Two massive galaxies will pass through each other, flinging countless stars into space. This isn't destruction, it's reorganization. A new supergalaxy will form 100 billion years from now. Cosmic expansion will push distant galaxies beyond our view. If intelligent beings are still watching the sky, they'll think their galaxy is all that exists. The universe will become an island. 10 trillion years from now, the raw materials for new stars will run out. Hydrogen clouds will fade. Star formation will slow to a crawl. The universe will enter a stellar desert. 100 trillion years from now, the last generation of stars will burn out. Natural light will disappear. Total darkness will fall. But that still isn't the end. Dead stars leave behind remnants. White dwarfs, neutron stars, black holes. These corpses last a long time. After about 10 to the power of 37 years, even protons may begin to decay. All atoms will fall apart. Rocks, metals, everything solid will dissolve into a soup of particles. All traces of what once existed will be erased. After 10 to the power of 67 years, recent research suggests that white dwarfs and neutron stars will evaporate through processes similar to Hawking radiation, much faster than scientists once expected. After 10 to the power of 100 years, even the largest black holes will vanish. All that remains will be photons, electrons, positrons, and countless neutrinos drifting through endless space, growing farther apart forever, and then swoosh, nothing happens. Temperature approaches absolute zero. Particles barely move. Time loses its meaning with no events to measure it. Time becomes like a frozen screen, forever showing the same frame. You can't tell whether it's a still image or a video that's stuck. That is heat death, not a dramatic explosion, not a heroic finale, just a silent fading away. At this point, you're probably wondering, is there any escape? Scientists are asking the same question. One idea is that the universe might not be a closed system. The second law applies to closed systems. If energy can flow in from other universes, if parallel universes exist, then entropy might not always increase. But so far, there's no evidence for that. Another idea involves gravity. Some physicists argue that heat death ignores gravity. Gravity pulls matter together, forming stars and galaxies. That looks like order fighting back against chaos, and gravitational systems never reach stable thermal equilibrium. So maybe true, heat death is impossible. Others disagree. They point out that while gravity creates structure, it also releases huge amounts of radiation, increasing overall disorder. So gravity doesn't reverse entropy, it just hides it temporarily. The most imaginative idea is cosmic reboot. Since the universe started in a low entropy state, could it return to something like that again? Physics has a theorem called Poincare recurrence. Given enough time, any system will return close to its original state. But enough time here means about 10 to the power of 10 to the power of 120 years. That's a number with 10 to the power of 120 zeros. Human language can't even describe it. So yes, in theory, the universe might restart. In practice, that's no different from never. All of this sounds depressing. If everything ends in nothing, what's the point of trying? But let's look at it differently. The universe is 13.8 billion years old. For most of that time, it was silent and empty. No life, nay, thought, no awareness. Then, one day, on a small blue planet orbiting an ordinary star on the edge of the Milky Way, a species emerged that could think, a species that looked up and asked, "What is the universe? Who am I? Where does it all end?" It took the universe 13.8 billion years to evolve eyes that could understand itself. We are those eyes. So the next time you feel like life is meaningless, remember this: you are the product of 13.8 billion years of cosmic evolution. You are a miracle, not yet erased by entropy. You are the brightest spark before the coming heat, death, and living well is the best way to resist the void.